In this brief video, we're going to try to show you how you can decide if a molecule has London dispersion force, dipole-dipole, and hydrogen bonding. Now, before you can apply this concept, you need to understand how to decide if a molecule is polar or nonpolar. There's another video that explains that. Hopefully it'll help out. But molecules all have electrons. If something has an electrons and it's a molecule, it will have London dispersion force. So all molecules, because they have electrons, that's what's holding them together, have London dispersion force. But the more electrons they have, the more London dispersion force they have. So something like hydrogen is only got 2 electrons, whereas fluorine has 2 times 9 electrons, so it has 18 electrons in total. This has much more London dispersion force. So it should have a higher boiling point than hydrogen. Sometimes it's not as simple as that. Now, in this case, both of these are nonpolar molecules. So the only kind of force they've got is London dispersion force. This molecule will have a higher boiling point because it has more electrons, because its boiling point is only determined by that particular intermolecular force. It becomes a little more complex for molecules that have electrons that are polar. So if it's a nonpolar, you only have London dispersion force. But if they're polar, they will have dipole-dipole force as well as London dispersion force. And this starts to get complex. So if the London dispersion force was exactly even, then it would depend on only which one is more polar. That's a little harder to define. But we'll be able to agree that you should be able to identify both, whether it has London dispersion force and dipole-dipole force. If it's polar, it does. If it's nonpolar, it doesn't. It only has a London dispersion force. If a molecule has got a huge amount of London dispersion force, even though it's the weakest force, it may still have quite a high boiling point, because the dipole-dipole interaction is a strong interaction, but it's not going to overpower a massive amount of this weak force. So we've got molecules. If they're nonpolar, only London dispersion force. If they're polar, they will have dipole-dipole and London dispersion force. But if they're polar and they have hydrogen bonded directly to nitrogen, oxygen, or fluorine, and we're talking about a direct bond here, where you've got a fluorine bonded to hydrogen, nitrogen bonded to hydrogen, or oxygen bonded to hydrogen, then it will have dipole-dipole, London dispersion force, and hydrogen bonding. And hydrogen bonding is an extremely strong dipole-dipole force, and it really affects the boiling point a lot. So something like water, which is a very small molecule, right? It's got 2 electrons here, and it's got another 8 electrons from oxygen, has a boiling point of 100 degrees Celsius. You need a much bigger nonpolar molecule to get that same boiling point. So molecules that have electrons, which is all of them, have London dispersion force. If they're polar, they have dipole-dipole force and London dispersion force. If they happen to have nitrogen bonded to hydrogen, fluorine bonded to oxygen, or fluorine bonded to hydrogen, oxygen bonded to hydrogen, they also have hydrogen bonding. Sometimes it's helpful to notice, though, that this is often written like OH or NH2 or something like that. If it's got a functional group that looks like this, a part of it that looks like this, it has hydrogen bonding, and by virtue of the fact that it's polar, it's going to have dipole-dipole bond, and it's a molecule, so it also has London dispersion force. So if you see something that's like an alcohol, like CH3OH, it's got all 3 kinds. If it's CH3NH2, it has all kinds of intermolecular force.